when we are going to classify a differential equation according to order, to degree, to type, whether it's linear or non-linear, homogeneous, non-homogeneous. And then later on, we will distinguish the families of solutions of a differential equation. Now, there are three classifications. In this topic, we will limit it to three classifications of differential equation. However, in advanced topics, we can classify, add more on this concept. We will limit it to order, degree, and type. When you say order, it's the degree, the order of the derivative, the order of the highest derivative in the equation. How many times are you going to integrate the differential equation to arrive at a function? That's the order. The degree is the largest power or exponent of, remember, the highest order derivative. So you look at the highest order derivative and you base your degree there. And then the type is, it could be ordinary or partial as to type. This is easy to distinguish because when you say ordinary, it has a symbol of letter D, but when it's partial, it has a symbol of inverted E. So let's have some examples, class. This one has first order. This is a derivative symbol in which you get the derivative of y in terms of x. So it's only first derivative. That's why it's first order. And there's no other derivative expression in the equation. Now, by the way, it's called differential equation because there is a left side of the equation, there is a right side of the equation. So it's a differential equation because also it contains a derivative expression. And it may be algebraic, it may be trigonometric, exponential, logarithmic, and even hyperbolic functions, or even inverse trigonometric functions. So kompleto yun, no? Now, second order naman is, you look at the expression of the derivative. This is the second derivative of y with respect to x. So it's second order. This case, it is also second order because the 3 there outside of the derivative expression is the degree. This refers now to the degree. So notice that in the second example that we have 2 derivatives. This is second order. This is first order right here. Okay, and in this case, this is second order, but the degree is 3. Ito naman is first order, and the degree is 1. So when you are asked of the order, you look at the highest derivative. In this case, this is second order, this is first order. Okay, so that's for the order. Now, ordinary differential equation may be classified also into 2, ordinary and partial. Differential equations, by the way. So we have ODE, PDE. This is the symbol and the inverted letter A for the partial differential equation. So it's easy to distinguish between these two. And you have ordinary derivatives. Y is a function of one independent variable. So as you can see, when you have an ODE, you have one dependent variable. On the upper part of the fraction is the dependent variable. X is the independent. You could also write this as y prime. Okay, class, y prime. For the partial derivative, u is a function of more than one independent variable. So the dependent variable could be more than one. The independent, by the way, the independent variable could be more than one. In this case, you can only see y, but one characteristic of a partial derivative is it could have more than one independent variable. Now, going back to ordinary differential equation, a differential equation is an equation containing a known function and its derivative. So you have an unknown function which you are going to solve, and there is a derivative expression. That's a derivative expression. So y is the dependent variable and x is independent. As you can see in these examples, y, which is in the upper part of the fraction, and x, the variable in the lower part of the fraction, is the independent variable. Now, let us verify the degree, the order. This is of order what? Order 1. This one is also of, no, this one is an order 2, because our derivative, the highest derivative is in 2. This is of order 3. Okay, this is of order 3. This one is first order of degree 4. Our partial differential equation, these are other other expressions of partial differential equation. You have, in this case, u as the dependent variable, x and y are independent variables. In this case, u as the dependent variable, and you have x and t as our independent variable. Ito naman is the same thing. Now, we classify the following, which is, what is the order, what is degree? I will justify kasi nakikita nyo na. Oh. Now, example number 1, the order is 1. As you can see, derivative, the order is 1. What's the degree? It's also 1. What's the type? It's ordinary. Example number 2, what's the order? It's 2. As you can see, derivative order is 2. And the degree is 1 kasi wala siyang degree dyan na naka-enclose, no? And it's ordinary. Now, number 3, as you can see, hindi mo nakikita yung dy dx. Pero pag ito ilipat mo sa kabila, you can see that, no, when you divide both sides of the equation by dx, then this one is, when the left side is multiplied by dx, divided by dx, cancel na yung dx dyan. Pero ito, pag i-divide mo ng dx, so you have a dy dx, which is of order 1. Kaya order 1 niya, degree is 1, this is ordinary. Number 4, this is of order, what order, class? Order 2, right? And this is the degree. We have another derivative, but you will always look at the highest derivative when identifying the degree. So order 2, degree 3, ordinary. This one is a partial derivative of order 2 and degree 1. Number 6, you have order 3 and degree 2. Okay, order 3, degree 2, and it is ordinary, right? Now, balik tayo dito, class. I want you to identify this one. What is the order? The order is? The order is 3. We look at the highest derivative. The order is 3 and the degree is?
4.
No, you look at the highest derivative pa rin. The order is 1. Yes, the order is 1. You have to remember the definition that we have. Ito. The order of the highest derivative. The largest power or exponent of the highest ordered derivative. So in number 3, in this example, the highest derivative is 3. So that is where you are going to base your degree. The order is 3 and the degree is 1. Not this one, kasi this is not the highest derivative. It has a degree of 4, but the order is 2. The order is 1. Kuha nyo, class. Okay, always remember, you look at the highest derivative. In this case, the highest derivative is 3. And that is where you are going to base your degree. And the degree in this case is 1. Right? Okay? Naintindihan nyo? Class?
Yes, ma'am.
Yes, ma'am.
Yes, thank you. So linear differential equation, These are the conditions for you to say it's linear. It is linear if the dependent variable, the y, and its derivatives are of degree 1. So it has to be of degree 1. In this case, this is degree 1. Why? This is of order 2 but degree 1. This is of order 1 and degree 1. Coefficients of a term does not depend upon the dependent variable. So there should be no y in this case. Whenever you see a derivative, there should be no variable y. So there's no y here. Let us have this one lagre sola. And so does this one satisfy condition number 1? Condition number 1, as I have said, dependent variable and its derivatives are of degree 1. Inspect each term. The first term, the dependent variable, of course, is y, and the derivatives are of degree 1. So the degree of the derivative is 1, as you can see, but the order is 2. The degree of the derivative is also 1. Order is 1. So this satisfies condition 1. Look at condition 2. Coefficients of a term does not depend upon the dependent variable. The coefficient here doesn't have a dependent variable, which is y, di ba? The coefficient here doesn't have a dependent variable. Wala naman tayong derivative dyan, kaya okay lang may y. Therefore, this is linear, class. This is linear. Example number 2. Example number 2 is the degree, the derivative, no, the order here, the order of the derivative is 3. And the degree is 1. All right? However, in term 2 or second term, the order, although it is 1, but the degree is 4. So it violates condition number 1, where it says dependent variable and its derivatives are of degree 1. The derivative here is of degree 1. However, in the second term, the degree is 4. So violation, immediately you will say, this is not linear. Okay? Not linear. Now, number 3, you look at the first term. We have a derivative of order 2 and degree 1. So it satisfies condition 1. Condition 2, there's no y variable as a coefficient. Okay. Term number 2, the order is of 1 and the degree is 1. So it satisfies condition 1. However, we have a y variable as a coefficient. Therefore, this is non-linear. Okay, class? Non-linear. Now, number 4, the derivative is of order 1. The degree is 1. Yes, correct. So we satisfy condition 1. In the right side of the equation, we have a trigonometric function where it involves the y variable, our dependent variable. So in this case, any expression that is not linear, when it involves a y variable, automatic yan, it is non-linear already, right? It's non-linear. Let's have more examples on that one later on. Nalilito pa kayo dyan. This one, what is it ordinary? As you can see, makikita mo na y prime, which is equivalent to dy dx. This is ordinary. This is ordinary. Ordinary, ordinary, ordinary. Partial. Partial. Alright? Partial derivative tong dalawa because of the symbol. Dito kayo malilito. Linear or non-linear. Mamaya. How about order? Well, you look at the derivative. Dy dx, order 1. Dy dx, squared, order 2. This is order 2, right? This is order 2, order 1. This is order 1, order 2. Okay? How about degree? Now, you look at the derivative. Dy dx, what's the degree? 1. What's the degree? Also is 1. What's the degree of the highest derivative? You don't look at the lower derivative or order of this one. See, you have two derivatives here. You look at the highest derivative. What's the degree? 3. So you write 3 here. In this case, this is our highest derivative. What's the degree? 1. What's the degree? 1. The degree is also 1. The degree is 1. Okay? Independent variable, that's easy to identify. Independent is in the lower part of the dy dx in that expression. So dy dx, x is the independent variable. X is the independent variable. X, this is x. You have x, y, z as independent variables. You have x and t as independent variables. With regards to dependent variables, you have y. You have y also, y. You have u, v, and w. These are multivariate because you have more than one dependent variables. And then you have u as as the dependent variable. Going back to linear or nonlinear, the number 1, this is linear class, no? This because it satisfies condition 1 and condition 2, right? This is also linear. Number 3, is this linear? Is this linear class? How about number 3? You look at number 3. Is it linear? So how about going back to number 4? Is it linear? Number 4. Anyone who would like to answer? Is number 4 linear?
Yung cosine po, ma'am.
Yes. Okay, take a look. The first term has a degree of 1. Although we have a second order derivative here, but the degree is 1. In the second term, we have an order of 1 and degree of 1. This is variable y. Now, the right side of the equation involves a trigonometric function, but the variable that's involved here is x, not the dependent. Not the dependent. So you look at what variable it is as a that is involved in the function of this trigonometric function. Therefore, this is linear class. This is still linear. Kung sana cosine 2y yan, then it becomes nonlinear. But this involves an x variable. So it's linear pa rin. Number 5.
Ma'am,
Yes?
ma'am,
Yes?
pag ang dependent variable po ba, ma'am, yung y, non-linear po, ma'am?
Yeah. No, pag dependent variable, in this case y, is a function of this expression na trigonometric, then it becomes non-linear. In this case, this is independent. This is x. So it is linear pa rin. Linear yan, class. Kasi nakalagay sa ating definition na coefficients, no, in the second example. Dito, in the fourth example, it is non-linear because sine of y, when you are going to graph this one, this is a sinusoidal function, class. So y minus y cubed over 3 factorial plus. This is non-linear. This is not unidirectional. So this is non-linear. It involves the y. However, in this case, it doesn't involve the y. It involves the x. So it is linear. Okay? Claro? Is it clear, class?
Okay po, ma'am.
Number 5 is linear, right? Number 6 is what? Linear or non-linear?
Linear po, ma'am.
Linear. Number 7 is
Linear po.
linear. Very good. Okay. Now let's go to first order still, no? Let's take up different forms of differential equation. A differential equation can be expressed in derivative form. Why it's called derivative form? Because you have a derivative dy dx. Buo sila. Hindi sila nagkahiwalay. So derivative form yan. When you have this expression na a sub 1x dy dx, or kung meron man yung d squared y over dx squared, tapos meron pang plus dy dx, so it is derivative. Differential form when magkahiwalay silang dalawa. So meron kang function na dy, no? Function in terms of dy or in terms of y minus y dx. So the differential form ito. General form naman, if it involves this expression na meron kang f of x and y. Or you could also write it as the function of x, y, and the derivative of y with respect to x. This is general form. So general form, again, we can have this expression. This is differential or derivative? This one is differential or derivative? Ano class?
Differential.
Differential form, okay? This one is what you call standard form of variable separable. Why it's called standard form? It's because nakagrupo yung lahat ng x, nakagrupo yung lahat ng y, which is already ready for integration. Kaya ang tawag dito, standard form. Meron kasi tayong mga standard form of Bernoulli equation, standard form of first order linear differential equation. So, in analytic geometry ninyo, meron tayong general form, meron tayong standard form. Example, the general form of a quadratic equation is ax squared plus bx plus c equals 0, correct? But the standard form, let's say, parabola, the standard form of a parabola, standard form of a circle. Standard form of circle is x squared plus y squared equals c squared. Yan, standard form yan. Standard form of a parabola is x minus h squared equals 4a y minus k. Yan, yung pagkakaiba ng standard form naman. Now, this one is a standard form for a variable separable. It's because it's now ready for integration, wherein the variable x is already grouped with derivative of x, and the variables y is already grouped with derivatives of y. Yan. So it's ready for integration. Now, first order ordinary differential equation, ito yung mga expressions na makikita nyo. So this is general form. This is still general form. This is differential form. This is derivative form. This is derivative form. This is derivative form. Okay, class? Wait. You may say this is derivative form as of now kasi hindi nyo pa na, wala pa tayong topic on first order differential equation, FOLDE. Pero actually class, kung kung pupunta or ma-discuss na natin yon, kasi sa ngayon wala pa kayong idea what FOLDE is, standard form of a FOLDE. But when we discuss FOLDE, you would say na this one is already the standard form of FOLDE. Standard form ito ng FOLDE class. Pero pag Bernoulli yan, may y to the n dito sa taas. Or meron siyang sa tabi niyang y to the n, then that is Bernoulli standard. Second order na derivative form, this is also derivative form. Alright. Pero hindi ito second order kasi naka y prime lang to. Bakit ba ito nahalo dito? So nth order, ito naman yung mga naka-n na siya, no? Tawag yan, nth order. Now, let us identify if it is homogeneous or non-homogeneous. The differential equation is homogeneous if every term contains the dependent variable or its derivative. Every term, you inspect every term. Does it contain the dependent variable or its derivative? So may derivative of y tayo. Tapos, okay, correct. May derivative of y tayo dyan. Tapos ito, may derivative of y ulit. Kasi nakalagay dito, it contains dependent variable or, so either, no? Or its derivative. First term, may dependent variable. Second term, may dependent variable. And the third term, mayroon tayong dependent variable. So it's called homogeneous class kasi every term. So sa left naman, zero naman yan eh. Homogeneous differential equation always has a trivial solution na y in terms of x equals 0. So that's homogeneous. Now, superposition principle are solutions to a linear homogeneous differential equation. We will take up on this kasi ito yung tinatawag na meron tayong particular solution, meron tayong complementary solution. So, wag na muna nating expound ito. Dito lang tayo sa not homogeneous differential equation. It is not homogeneous if at least one term, if it has at least one term that contains no dependent variable. So we have identified our dependent variable as y. The first term has a dependent variable. The second term has a dependent variable. But on the right side, we only have x. Wala tayong y. So this is not homogeneous. Right? So we will discuss more on this next time. Solutions. Ito, solution tayo. Solution of a differential equation could be a particular solution. You may express it if there is an initial condition. There is no arbitrary constants. Ano yung arbitrary constants? Yun yung after integrating, meron kang c. Kung isang beses ka nag-integrate, tawagin mo yung c. Pero pag dalawang beses ka nang nag-integrate, meron ka ng c sub 1, meron ka ng c sub 2, and kung ilang beses ka nag-integrate, kaya meron kang c sub n. Now, general solution is at least one arbitrary constants ka. No? Kaya ito, walang arbitrary constant kasi may initial condition, sinubstitute mo yung value ng x and y, kaya na-eliminate yung arbitrary constant, na-solve mo siya. No, not na-eliminate, na-solve. Sa general solution naman, meron kang arbitrary constants. Now, let's have an example. Itong solution na y is equal to 3x plus c, function na to class, no? It's the solution of the first order differential equation y. Kasi c lang siya eh. C sub 1 or c. You don't need to put sub 1 kung isang beses ka lang nag-integrate. So, tawagin mo lang siyang c. Maglalagay ka ng c sub 1 kung alam mong meron pa siyang second integration. Right? So, ang tawag dito, general solution. Now, ito naman, y prime is equal to sine of x. And so, when you integrate this, so integrate both sides, the integral of y prime is y. The integral of sine of x is negative cosine of x. You always have to add plus c. And then if you are going to, also another example, you have a double prime, no? So integrate both sides. The integral of y double prime is y prime. The integral of 6x is 3. This is, kasi mag-a-add ka, no? 6x squared over 2. So meron ka ngayong 6 over 2 is 3. Kaya 3x squared, which is this one. The integral of e to the x is still e to the x. Pero palagi kang maglalagay ng plus c sub 1 kasi nag-integrate ka, di ba? Now, since hindi pa siya na-expose kasi nga, meron ka pa rin derivative. Kaya hindi ka titigil hanggang meron kang derivative para makuha mo yung function. Integrate both sides. So, you come up with y is equal to, ano to? 3x cubed over 3. Kaya mag-cancel na yung 3 and 3. So x cubed na lang. Integral of e to the x is e to the x. What is the integral of c1 dx? O the c1x yon. Plus c sub 2. Kasi nag-integrate ka ulit. Kuha niyo, class? So that Ito yung note. Observe that the set of solutions to the above first order equation has one parameter while the solutions to the above second order equation depend on two parameters. Kasi ito, meron siyang C. So one parameter lang. Ito, meron siyang C sub 1, meron siyang C sub 2. Kaya dalawa yung kailangang initial conditions para ma-solve mo yung arbitrary constants na C sub 1 plus C sub 2. Okay, class? So, nag-ano lang tayo, nag-orient lang tayo on different nature of differential equation. Anong classification meron siya? Ano ang mga solution niya? Meron siyang partial, meron siyang meron siyang particular solution, meron siyang general solution. Now, families of solutions naman, we all know na ang differential equation, pagka i-solve mo yan, you will arrive at a function. Diba? Kaya ito, solution nito, edi integrate mo isa-isa. Kasi what's the integral of 9y dy dx? No. What is the integral of 4x dx? Ayan. Kaya ito, pag i-distribute mo yung integral sign, meron ka ngayong 9y, ito dy dx, times dx, edi dy na lang. Kaya itong maiwan. Ito naman, the integral of 4x dx is 4x dx. Okay? So, equated to c sub 1. So, mag-i-integrate ka na ngayon. The integral of 9y dy is 9y squared over 2. Ito yon. The integral of 4x, hindi lang to na dapat ito ay 4x pa lang para sabay-sabay. So the integral of 4x is of course 4x squared over 2, but 4 over 2 is 2. So meron kang 2x squared. And then plus c sub 1, equated to c sub 1. Okay? Now, nag-integrate ka dito, so dapat sana meron ka ditong plus C. Yung C and then another C, tatawagin mo rin yung C. Okay lang, no? Actually, class, yung integral, kasi kung naka-equate ito sa 0, kung naka-equate ito sa C sub 1, alam naman natin constant to. And the integral of a constant is another constant. Diba? The integral of a constant is the derivative of a constant pala is 0. So therefore, the integral of 0 is what? Is a constant. Diba? The integral of 0 is a constant. So therefore, yung c sub 1 dito, pag i-integrate mo both sides, actually itong process, okay, what happens here, ito, titingnan nyo to class ha, itong part na to, ito. Ayan. Ayan. Paano nangyari na nawala yung 2 dyan? Multiply both sides by 2. Pag multiply mo ng both sides by 2, mag-cancel na yung 2 dito. Kaya ito nagiging 4. So 4 yan. Tapos ito, multiplied by 2, kaya nagiging 2c. Or, if you're going to simplify this into its standard form, you will notice na pag i-divide ko tong both sides ng 9 times 4, pag i-divide ko to ng 9 times 4, mag-cancel yung 9 over 4. Divide ko to ng 9 times 4, mag-cancel ang 4 over 9. Kaya ito yon. Tapos ito, i-divide ko ng 9 times 4, constant lang din naman yon. Constant and another constant is still constant. Tawagin na lang natin siyang C. Actually, class ito, this is an equation of an ellipse. Alala nyo? Standard form. Kaya, concentric ellipses, yun. Yan siya, no, class? Anong application ng differential equation? It can be applied in geometric problems, wherein what we can solve are functions of lines, functions of curves. Then we can apply also in physics problems like acceleration of a free falling object, spring, vertical displacement of a spring, We can apply differential equation in circuits, also with concepts of Newton's law of cooling.